Hello, this video tutorial is to explain how to solve the focused questions for grade 9 ASP end of term 1 exam. Let's first begin with topic 1.1. Which of the following best describes a hypothesis? In a scientific steps or scientific methods, there are many steps that we usually follow in order to reach a theory or a law. So you are responsible to know the difference of or the meaning or what is every step of this scientific method. So a detailed step-by-step procedure to test an idea, that's an experiment. A statement based on repeated patterns in nature, that's a law. A tentative explanation that can be tested by experiments, a tentative, it's like a guess, that's a hypothesis. And a record of what is perceived using senses, what you see, what you observe, the results that you obtain, this is called observation. So in this question, they are asking you, which of the following best describes a hypothesis? The correct answer is C. A student writes down, the metal feels cold to touch. He used his senses and he touched the metal and it feels cold. So that's not a theory. That's not a guess because it doesn't start with an if. That's not a law. This is what he observed and what he felt using his senses. It's an observation. A student writes, if salt is added to water, the freezing point of water will decrease. The student still not sure if this sentence or if this fact is correct. If he added salt to the water, will the freezing water changes? He is not sure. So that's a tentative statement, explanation that needs to be tested by trying to add salt to the water. So what we have here is a hypothesis because it's a guess, we're not yet sure. Now moving on, which of the following does not have any ordered pattern in its particle? We are talking about solids, and you know that we have two types of solids, the crystalline and the amorphous. The crystalline are the structures that are very arranged, ordered. So ordered, arranged, highly arranged, like crystals. And the amorphous are the solids that you do not see an order within their particles. They are not ordered. So table salt is made up of crystals, ionic compound. So it is a crystalline structure. Ice, same thing, and diamond, same thing. Now, ice is not an ionic compound, but it makes crystals. So the water molecules are highly arranged when they become solid. And diamond as well, because in crystalline solids, we have the example of diamond, any ionic compound, any jewelries, gems, all kind of crystals falls under the category of crystalline solid. But glass, rubber, plastic, these are amorphous solids. Classify each of the following diagrams as element, compound, or mixture. Now, to clarify the difference between them, when I say a mixture, it means that I have two or more different species. The species could be compounds, could be element, but they are different. They're not the same. Now, a compound means I have a molecule. Now, the compound is made up of at least two or more different elements. Element, it could be a single or a diatomic one. So let's see here Let's finish up with the mixture, or let me look at this one. I have an atom bonded to two different atoms. So what I see here is a compound, whereas here I have the same atoms bonded together. So what I see is an element. So that's a compound, and that's an element. Now, all of these are the same, so that's not a mixture. Also here, all of them, they have the same structure. That's not a mixture. Now, looking here, here I have an element. And over here, because the atoms are different, I have a compound. So this structure is different than this one. So I have here a mixture. And if they ask you for more details, a mixture of element and compound. Element with compound. So that's your mixture over here. Now, here, it's an element. Okay, this element is in the solid state, but still, it's an element made up of one type of particle. This one, this structure looks like this, like this. All of the structures are the same, so that's not a mixture. But I have three different atoms in one structure, so it means I have a compound. Now here, I have a single element. Still, it's an element, not a compound. And not a mixture, just an element. Let's continue. This is the part where we talk about physical and chemical changes. Physical change, the difference in the physical change, the substance keep its identity. The identity is not changed. So if I cut a paper, the paper is still a paper. It didn't turn into something else. But for the chemical change, identity changes. So if I am burning a paper, the paper is going to turn into ash. It's not anymore a paper. Now, there are some words that you can pick up in the question that helps you identify that this is a chemical or a physical change. So, here, for example, react, rust, burn, combust. All of these, these words will identify, will help me understand that this is a chemical change that's going on. Okay? I might get more words later on in the questions. In the physical, cutting, breaking, grinding, like making it a powder, melting, freezing, so melting, freezing, evaporating, any physical change. These identify that I have a physical change. So, which of the following is not a physical change? When you read questions like this, they're a bit confusing. I advise you to write next to each one what kind of change is this, and then you see what the question wants. Cutting a paper, that's a physical. Hammering iron, because iron is a metal, it's malleable, so we are hammering it, changing its shape, but the iron is still an iron, so that is a physical change. Iron rusting, with the effect of humidity and oxygen in the atmosphere, the iron rust, so that is a chemical change. Melting of ice, melting of metal, melting of whatever, that is physical. So here in the question, they want what's not physical. So here's the answer. Consider the diagram below to answer questions 7 and 8. So before we look at the question, let's look at the technique. Apparently, I have a liquid here, and I have a solid precipitating down. Now we're dropping slowly the liquid over a mixing, this is not a stirring rod. This is called a stirring rod. So what happens is that only the liquid will come here and the solid will remain. So we're kind of doing a separation technique here. So what's the name of this separation technique? This is called decantation. This is not a filtration because I don't see a funnel and I don't have a filter paper. So that's not a filtration, that's a decantation. This technique can be used to separate homogeneous mixture. Not at all, because in a homogeneous mixture, I wouldn't see a solid deposited at the bottom like this. So this technique and this technique and the filtration technique as well, and the filtration technique, yes, these techniques are used to separate heterogeneous mixtures. So therefore heterogeneous, not for homogeneous. Now, here is another technique. From this technique, I have something called distillation. But you know that you have two types of distillation. So this is the distillation. A distillation could be simple and it could be fractional. The difference between them is a fractionating column. So what I see here is a fractional distillation. I'll see if in my notes during the course of this term, I showed you some photos of the simple distillation. This column here will not be there. And this column here is essential to separate homogeneous mixture having components having boiling point that they are close to each other. So let's see what do they want in this question. So they want the name of this separation technique. That's fractional distillation. Distillation in general is used to separate homogeneous mixtures, not heterogeneous, homogeneous mixtures, and based on the difference in their boiling point. But when we use simple distillation, it means that the components of that mixture, their boiling point are far away from each other. So the boiling point are so much like difference, there's a big difference between their boiling point, then I will have to use simple distillation. But for fractional distillations, the components of that homogeneous mixture will have close boiling points that we need a fractionating column in order to separate them because their boiling points is very close. So this technique is used to separate homogeneous mixtures for miscible, like liquids that can mix. This technique can be used to separate mixtures of ethanol and water depending on the difference of their boiling point. Yes, that is correct. Moving on to topic 1.2, which is about matter, atom, molecules, and compounds. The smallest particle of an element that retains its identity in a chemical reaction is the atom. The neutron and electrons are inside the atom, but these are subparticles. We are talking about the smallest particle of an element. A molecule is like two elements or more together. So I cannot choose it. Energy is defined by the ability to do work. The force applied over a distance, not the total mass of an object, that's a mass. The type of matter, it's like a solid, liquid, or gas. So energy is the ability to do work. Chemical potential energy. Whenever I say in chemistry potential, it means it's the energy stored in bonds. We eat a bar chocolate to get the energy stored in that chocolate so that we can run and go and do some exercise. We eat food to get the energy from that food so that our body will function and our organs will grow. So chemical potential energy, it's the energy stored in the bonds. Which of the following is not an extensive property? We studied this term, the difference between intensive and extensive property. And I explained that intensive, they are independent of the amount, of the quantity. Like, for example, color. Whether the object is a small or large, the color is a color. Or temperature. But extensive properties could be like mass, volume, weight, distance, length. So all of these are extensive properties. So weight. So here they want us to find the one that is not extensive. So they want the intensive property. Mass depends on quantity, volume and weight also. Density, whether an object float or sink. Other than density, conductivity is an intensive property. Reactivity, whether an object is large or small, it's still going to react in a different way. Or temperature, all of these are intensive properties. So here's a better question so that you can know the difference between them. Whenever you get this in the exam, write on top of intensive, independent of amount. Anything that has nothing to do with the amount is an intensive. So color is intensive. Combustibility, something that can burn or not. So that is intensive regardless of the quantity. I can burn a big log of wood and I can burn a small piece of paper. Hardness or softness, intensive. There is no softness here, but hardness or softness, both are intensive properties. Mass depends on quantity. Whether it's small or large, mass would be small or large. Volume as well. Weight as well. So these three are the only one extensive property, extensive and extensive. Now let me continue with the others. Melting point. Water will melt at 100 will melt at 0 degrees Celsius. Whether I have a lot of ice or a small portion of ice, they will melt at the same temperature. So that is intensive. Ductility, the ability to make wires from something. So it is intensive. It doesn't matter the quantity. Reactivity with acid or reactivity with oxygen or reactivity with metal. Reactivity in general doesn't have to be necessary with acid. This is intensive. Odor, whether an object is small or large, if it has an odor, it has an odor. Now the odor could be strong or could be weak, but still it's an odor. So it is an intensive. Malleability, the ability to bend an object without breaking it. So that is intensive property. And tendency to corrode. To corrode means to rust. So also that is an intensive property. It has nothing to do with the quantity. Which of the following is considered intensive? So it does not depend on the amount. The height, extensive. The alcohol is flammable, intensive. The mass, extensive. The volume, extensive. So the answer is B. Moving on. Modeling atoms. So It's this part of the lesson where you have to look at atoms and know the symbol that they are giving you. Now, in your exam, when you look at the periodic table that you will receive, I hope that you will check it along with the formula sheet, is made up of boxes. You see the symbol of the element in the middle. Like, for example, let me take Mn. On top of it, there's a number. I'll explain it. And down, there's also a number with decimal places, 54.938. Because some other periodic tables, they have the numbers flipped. So I really need you to understand those numbers and what do they mean, so that you will know when you have a question how to use those numbers and how to answer. So, since 25 is smaller than 54, 25 in the periodic table that is going to be given in your exam is what we call atomic number, symbolized by Z. The atomic number will give you how many protons and will give you which is equal to how many electrons. So from the atomic number, I can know how many protons I have and how many electrons I have, because they are equal. Like, for example, in this one, Z is equal 25, but we also have 25 protons and 25 electrons. Now, the number at the bottom, because the number given in your periodic table is a decimal number, it's not a whole number, it means that is called average atomic mass. In order to use it and answer these kind of questions, you need to round it. So this average atomic mass, when you round it, like for example here, 54.9, it's gonna become 55. When you round it, you can call it mass number, which is symbol A. Okay? And you need to do that in your exam because the numbers are not rounded. We have two parts, two important things included in your exam. The average atomic mass, calculating the mass of isotopes, is part of your exam. So that's why they are giving you the numbers with decimal places. But for the sake of questions where you have to calculate the atomic number, atomic mass, you need to round that number. So here, this is now 55, and I call it the mass number. The mass number will give me the amount of protons plus neutrons. So having the number of protons from Z, we can subtract A minus Z, and then we can know how many neutrons. So let's see here what do they want in this question. Which of the following sets is the symbol of the element? The number of protons and the number of electrons are given correctly. Well, they want to check if the symbol given here has the correct number of protons and electrons. Without going to the periodic table, I can eliminate B and I can eliminate C, because in an atom, the protons must be equal to the electrons, and in this case, they're not. So that's wrong, that's wrong. Now, I need to go and check in my periodic table if indium has really 49 protons or the fluorine has the 19 protons. Now I'm gonna take you to the periodic table given to you. So this is the one I'm talking about. This is F. As you can see here, they rounded the number to 19, but 19 is a mass number, not a proton. F has 9 protons. Now let me take you to indium. It's over here. 114, which is rounded to 115, that's the mass number. But 49 is the number of protons. So the correct answer over here is indium. So A is the correct answer. Next, the atom below has a mass number of 23 with, they want to know, so the mass number is A, they want to know how many protons, and they want to know how many neutrons. Now, let's count. I know for the fact that proton is equal to electrons. So if I count the electrons here, I can know the protons. 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 electrons, so we have 9 protons. Now, to find the neutrons, A equal Z plus N. A is 23, and Z is the amount of protons, that is 9. So in order to find how many neutrons, we only need to subtract. So 23 minus 9. So the answer is, oh, what a shame. So 23 minus 9, 14. 14 neutrons. 14 neutrons. So here, 9, well, none of these is a correct answer. Well, yeah, there is a mistake in this question, or maybe this number is not correct. But what I can see here, I'm just gonna double check the number of electrons to see if I counted correctly. 1, 2, 4, 6, 8. Oh, I counted wrong. 10, 11. Okay, my mistake. So it is 11 electrons. 11 electrons. Okay, it's here. 11 electrons means 11 protons. You see, you have to be careful not to do this mistake in the exam. 11. So yeah, now it is correct. It makes sense. We continue. Consider the element Z, 21 and 10. Be careful to the location of the numbers. Always the bigger or the larger number is A. The smaller number is the atomic number, Z. Because some periodic tables, they might write it like that. So you have to be careful. So, which of the following is true? Now this has protons and neutrons. This has just protons, which are equal to electrons. And since here I can see that they are counting neutrons, I can do 21 minus 10. I know that I have 11 neutrons. So let's see. This element has 21 neutrons. Don't continue, that's wrong. The element has 11 protons. That's wrong, it has 10. This element has 21. This element has 11 neutrons and 10 electrons. Now we reach the part of isotopes. The periodic table can help you a lot to guess your answer, to double check actually your answer. Gallium has 2 naturally occurring isotopes. The mass of gallium, 69, is 68.9256 AMU, and it is 60% abundant. So isotope 1, always write the given. Isotope 1 is 68.909,256 AMU, and the percentage is 60.108. That's isotope 1. Isotope 2 is 70 AMU and 39%. So I'm going to write it over here. Isotope 2 is 70.9247 AMU, and the percentage is 39.892%. Now, before you start solving, you can use your periodic table to predict your answer. Here's the periodic table, and this is gallium. You should obtain an answer that is very, 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 very close to this value, if not the same. But in the exam, you cannot go to the periodic table and say, here you go, that's the number. No, you need to solve. And how do we do this? We multiply the mass by the percentage over 100. We multiply the mass by the percentage over 100, and then we add both of them. It means like this: 68.92 times 60.108 over 100. That's the portion of isotope 1. And 70.9247 times 39.892 over 100. Don't forget the 100. Or you can divide here by 100, which is 0.39892, and you multiply the value by this one. It's the same. So the answer is going to be 69.7231 AMU. Don't forget the unit. That's it. Calculate the atomic mass of silicon. So I have silicon. I'm going to go check my periodic table for silicon. Silicon has 3 isotopes with atomic masses and relative abundances. So that's the mass, that's the abundance, that's the mass, that's the abundance, and that's the mass, with this the abundance. So what I'm gonna do, for every isotope, I am going to calculate it. 27.9769 times the abundance over 100. For this one, I'm gonna also do the same. 28.9765 times the abundance over 100. And for this one, again, I'm gonna do 29.9738 times 3.0872 over 100. What I'm gonna do is I'm going to find the answer of each one, and then I'll add them all. So the answer of the first one is 25.8303 AMU. And for the second one, it is 1.3570. And for the third, 0.9 AMU, 0.9253 AMU. Now when I add these values together, I am going to get exactly the answer in the periodic table. And I'm going to show it to you just to prove it. So here's your periodic table. Here's the silicon. It is 28.086. So that is exactly the answer that we are going to get. So you can double check your answer if it's correct by checking the periodic table. AMU. Don't forget the unit. Bromine has 2 naturally occurring isotopes, bromine 79 with a mass of 78,918 AMU and is 50% abundant. Okay, they didn't give me the abundance of the second isotope because they said 2 naturally occurring isotopes. Okay, that's not a problem. We know that this is a percentage. So let's find out the percentage of the other isotope, which is bromine 81, of the second isotope. So the percentage of the second isotope is 100 minus the first percentage, and that is 49.31%. Okay, great. So I have 2 isotopes, isotope 1 and isotope 2. Isotope 1 is 50 49.69 abundant, isotope 2 49.31 abundant. Isotope 1 has a 78.918, so 78.918 AMU, and let's continue the question to see the mass of the second. Using the atomic mass reported on the periodic table, oh, they want us to find this. Okay, so I'm just gonna make it simple. Usually, we multiply the abundance by the mass, we divide by 100, and then we do the same for the second one, except that this one I don't know the mass, over 100, and we get the answer AMU. Now what I'm gonna do, because it's the same answer obtained in the periodic table, I'm gonna go to bromine and get that answer. So let's go to BR, and it is 79.904. So 79, oh, it didn't save. Let me just write it here. 79.904. So again, I'm gonna repeat. I have only I have two isotopes. Two isotopes given in this question for BR. The first isotope, 50.69%, with a mass of 78.918 AMU. The second isotope, they didn't give me the percentage, but I can do 100 minus 50.69, and I will get it to be 49.31%. So now I have the abundance of isotope 1 with its mass and the abundance of isotope 2, but I don't know the mass. When I multiply these together and I divide by 100, and when I multiply these together and I divide by 100, I add the answers to get the mass that I'm finding it in the periodic table. So here it is. That's how I'm going to write it. 50.69 times the mass of the first isotope over 100 plus 49.31 times the mass that we need to find over 100. Now the answer, we usually get it, but this time we found it in the periodic table to be 79.904. So now I need to calculate and start distributing and solving. So for this one over here, I'm just gonna get the answer. 50.69 times 78.918 over 100. So my answer to the first one here is 40.0035 plus, I'm gonna divide this value and leave it next to the mass, 0.4931 mass equals 79.904. Now 0.4931 mass that we are finding equal 79 minus 40.0035. So that is equal to 79.904, 39.946. Now, if I want to find the mass, I'm going to divide, and I'll get the mass of the second isotope to be 0.4931, 0.917 AMU. That is your final answer. If you find this question hard, watch my video tutorial of isotopes. There are more practice questions for finding the mass of isotopes. An element has two naturally occurring isotopes. Calculate the mass of this element. Well, here I cannot use the periodic table. They're not telling me what is this element. So what I need to do, I need to multiply those over 100. I need to multiply those over 100, and then I add my answers. So the average atomic mass is equal to 19.1 times 20 over 100 plus 20.2 times 80 over 100. My final answer is going to be 19.98 AMU. Don't forget the unit. Moving on. Which of the following electronic transitions in oxygen atom will result in light emissions? So, I need to pay attention to this question. In light emission, when an electron goes from a higher level to a lower level, it emits light. But when an electron jumps from a lower level to a higher level, in order to do that, it absorbs light. So be careful to the question. Emit light or release light. So here, they are talking about the emission. So you're gonna choose any option that's showing you a transition from a higher number to a lower number. If a hydrogen atom emits red, green, and blue, in the question they gave you 3 colors. When they give you 3 colors, it means 4 energy levels are involved. Because the electrons are going to, every color is a transition from a level to another level. So 1, 2, 3, 4. Now, these questions could be confusing. If this question said, if a hydrogen atom emits red and green light, how many energy levels does it have in the visible region? Because they mentioned 2 colors, you will choose 3 energy levels. Is this clear? I hope that this is clear for you. If they answer or if they tell you in the question 1 color, it means 2 energy levels. 2 colors, 3 energy levels. 3 colors, 4 energy levels. 4 colors, so 5 energy levels are involved. So in this question, I have red, green, blue. So that is 3, meaning 4 energy levels involved. Why does each element have a unique emission spectrum? Because the emission spectrums are like fingerprints. They are specific and unique for every atom. And this is how, based on the emission spectrum, we were able to identify the kind of every element. And every element, the transition of its own electrons is different from other elements. So every element has a different nuclei that does not affect the emission spectrum. The protons, it's a unique emission spectrum. It's all related to the transitioning of the electrons, the way they transition between the energy levels. Moving on. What is the lowest possible energy level? Lowest possible energy level. an electron can occupy. It is the definition of a ground state. Now, excited state, when an electron gain energy, it becomes excited and move to a higher level. So that is called excited state. Outermost state, there is no such thing. We usually say outermost energy level, and that is the last level occupied with electrons. Fundamental state, there is no such thing in chemistry. In a chemical reaction, 12 grams of hydrogen reacts with 16 grams of oxygen to give me water. So I took 12 grams and I added for them 16 grams. Now I want to know how much water I'm going to get. I'm going to get 28 because we follow the law of conservation of mass. It means the mass before is equal to the mass after. Which of the following is an example of energy conservation, like to save energy, not to lose it in a chemical reaction? Atoms being destroyed? No, they do not get destroyed. Mass does not disappear in a reaction. The reaction doesn't produce unlimited energy. The water boiling and converting chemical energy to heat. Yes, when water boils, we can feel the heat coming from it because there was chemical energy stored in this water between the water molecules, and when they turned into gas, we can feel this temperature. So here we got a conversion. In a closed system, when magnesium reacts with oxygen to form magnesium oxide, so I have a system closed. I have magnesium reacting with oxygen. Because the system is closed, nothing's gonna escape. So whatever mass I have for magnesium and oxygen, it is going to be the mass of magnesium oxide. So the mass does not change, and I showed you this in an experiment. The mass will not change, it will remain the same. The diagram shown represents the law of conservation of mass, the law of saving mass. It means mass before equal mass after. The missing mass of hydrogen. So 18 minus 16, and I'm gonna get the answer because 16 plus that number is gonna give me 18. 24 grams of magnesium reacted with 40 with oxygen. Reacted with oxygen. So 24 gram magnesium reacted with oxygen, and it formed 40 grams magnesium oxide. How much mass of oxygen we have? So you subtract and you get the answer. Periodic table of the elements. How was the periodic table created? And the work of the scientists who came throughout the years and classified the elements. We were interested in Dobrynin, Newlands, and Mendeleev. Who is credited with organizing the elements into triads? Triads, that is Dobrynin. Newlands, octaves. He grouped the periodic table, similar like the piano, into octaves. Mendeleev grouped the periodic table based on similar properties of increasing atomic mass. So Dobrynin, the triads, Newlands, the octaves, Mendeleev, similar properties, but he grouped them all. How did John Newland contribute to the development of the periodic table? So again, as I said, the triads for Dobrynin. He arranged elements by atomic number. Well, later on, we didn't study this, but this is for Moseley. He predicted the existence of undiscovered elements. That was Mendeleev. He created the law of octaves, where every 8 shared similar properties. That is Newlands. So that's the answer. How did Mendeleev arrange his elements in the periodic table? He arranged them by atomic mass, but later on, another scientist came and he arranged them the way we have them today, by atomic number. Now, consider the elements in the table below to match with the best description from question 37 to 43. Okay, so these are the questions, and we're going to select from here to write our answers. A solid metal. Well, first, before I move on, let me examine the element that I have. Hydrogen. Hydrogen is a non-metal, and it's in the periodic table, and it's a gas. And it forms a diatomic molecule. Xenon is a non-metal. I'm just going to write non-metal. Well, you have to go to the periodic table and check their location in order to know. Xenon is a gas. Carbon is a non-metal, but it's a solid. I gave you the physical properties of these elements. Barium is a metal. All metals are solid except mercury. You just have to look for barium and you will find the location. Arsenic is it's on the stairs. It's a metalloid, but also it's a solid. Nitrogen, it can form a diatomic molecule. It's a non-metal and it's a gas. I'm going to take you to the periodic table and show you the location of these elements. So, we're talking about hydrogen. We're talking about xenon, carbon, barium. You see the location? It's on the metallic side. Arsenic, it's on the stairs here. Arsenic and nitrogen. Use your periodic table to make this question easy. A solid. I do have more than one solid, but they want the solid metal. So that is barium. We're done. Let me see. Oh, we can use the answer more than one time. So hang on. A gaseous gas, non-metal. I have nitrogen and I have hydrogen. This is a gaseous non-metal. But located on the right side. This is on the left. That is on the right. Nitrogen. Barium. I don't have to write the full name. I can just use the symbols. A metalloid, that's arsenic. A gaseous non-metal on the left, that is hydrogen. A non-metal with 8 valence electrons, it means group 18, that's xenon. A solid non-metal, that's the non-metal that is solid, that is carbon. A metal with 2 valence electron, it means it has to be in group 2, and it's a metal. So non-metal, no, barium. Let's continue. Check the Bohr's diagram below to answer questions 44 to 46. So, which of the 2 atoms will form a cation? Before I do this, let me just understand more about beryllium and fluorine. Since beryllium is written here, beryllium has 2 valence electrons. Beryllium belongs to group 2. Beryllium is a metal. Beryllium is gonna lose those 2 electrons. Beryllium is gonna become positive. Okay. Fluorine. Fluorine has 2, 4, 6, 7 valence electrons. Fluorine belongs to group 17. Fluorine is a non-metal. Fluorine is going to gain electrons. Fluorine is going to turn out to be a negative anion. Negative anion. Whereas beryllium, when it becomes positive, it's a cation. So let's start with the questions. Which of the two will form a cation? Beryllium. Why? Because it is a metal that will lose electrons, and basically 2 electrons. They didn't tell me, but I can say lose electrons in general or specify how much. Which of the two atoms will form an anion? Fluorine, because it is a non-metal, and non-metals usually gain electrons. That will gain, if I want to specify, this is 7, it's going to gain 1 electron. What type of bond formed between these two atoms? This is a metal transferring electron to a non-metal. We are talking about an ionic bond. The justification is because a metal will transfer electron to a non-metal. Or you can say because it's formed between positive and negative ions. This could be also an explanation. Or you can simply say because it's between a metal and a non-metal. Now, another question. They want us to identify the anion, okay. I don't have to count all the electrons. All I need to count is how many valence. So here I have 2, 4, 6 valence electrons. It means this belongs to group 16. It means that is a non-metal. It means that it's going to gain 2 electrons. And it becomes a negative anion. I said all the information. Now this one, 1, 2 valence electrons, meaning it belongs to group 2. It means that that's a metal that will lose 2 electrons to become positive cation. Okay. So, identify the cation Q, the anion M. What holds the ions together in an ionic bond? Ions in an ionic bonds are held together by the electrostatic force of attraction, are held together by the electrostatic, it's a force between charges, electrostatic force of attraction between oppositely charged ions. You have to say all of this in your exam. What is an ionic bond? We just said it. It's a bond formed by transferring electrons between a metal and a non-metal. We never share protons. Between two metals, it's a metallic bond. Sharing electrons, that is a covalent bond. What is a covalent bond? It is formed by sharing. Sharing, definitely not proton. It's sharing electrons between two nonmetals. What is a metallic bond? Metallic bond, there is a sea of delocalized electrons moving around a lattice of positive ions. So, it's not between nonmetals. It doesn't involve a transfer for ionic. It's not between a metal and a nonmetal, that's for ionic. But the metallic, it involves sharing free electrons. So these are mobile moving electrons. They are moving around a lattice of positive ions, metals. What is the octet rule? Octet rule is when the atoms, they lose or gain or share their electrons to become stable like a noble gas. And I mean by this to have 8 valence electron. That's why we say octet means 8. So atoms tend to lose, gain to have 8 valence electrons. Why do atoms form chemical bonds according to the octet rule? They do this because they want to become stable and they want to become like noble gases. They want to achieve a full outermost energy level. So to achieve an outermost energy level of 8, protons and neutrons are wrong. Which of the following is not a property of ionic compounds? You need to memorize the properties of ionic compound, and this specifically the property that says that ionic compounds conduct electricity when molten or when dissolved, but not when solid. So here, what is not a property? Ionic compound are hard. Ionic compound dissolves in water. Ionic compound, okay, they have a high melting and boiling point. But ionic compound, they conduct electricity when molten or when dissolved, not in solid. Which of the following is a characteristic of ionic compound? They're not malleable. They don't have a low melting point. They are a good electrical conductor, but not in the solid form. Yes, and all of them are solids. They're crystals. So that's the answer. How does the structure of ionic compounds affect their properties? The crystal lattice of ionic compounds, this hard structure, these ions that are held together with those electrostatic forces are the one affecting the properties of an ionic compound. They are the one making it solid. They are the one making it hard, brittle, and crystal. So that's not the case. Ionic compounds are not malleable. The free movement of electrons, we don't have electrons freely moving. We have ions moving in the ionic compound when they are dissolved. The strong electrostatic forces between these ions are the one behind the reason why they have a high melting and boiling point. Why do solid ionic compounds not conduct electricity, but when they are molten or even dissolved, they do? What's the problem? In the solid ionic compounds, ions are locked, are in fixed position. Many students, they get this wrong and they start saying electrons. That is completely wrong. Solid ionic compounds contain covalent. Wrong. Solid ionic compounds contain no ions. No. In the solid state, ions are fixed in a lattice. But in the molten, ions are free to move. Look at the last choice. In the solid state, atoms share electrons. No, they don't share anything. Single covalent bonds, double and triple. A single covalent bond is whenever two atoms, non-metal, sharing 2 electrons or 1 pair of electrons, which is C. Which of the following has a triple covalent bond? You need to know the structure of these molecules. Oxygen, chlorine. This is the same as fluorine, bromine, iodine. Exactly the same. You just have to change the symbol in here, like F, Cl, etc. Okay? So let me just put it back. Now, hydrogen is like this. So which one has a triple covalent bond? this one, and here double, and these two single. Kinetic molecular theory. What is kinetic energy? It's the energy of motion. Position is related to potential. How does kinetic energy relate to the motion of the particles in matter? The more motion, the higher the kinetic energy. They move faster, it means they have more energy. So the higher kinetic energy makes particles move faster. According to kinetic molecular theory, gas particles, describe the gas particles here. They do not attract, they are not stationary, they move all the time. So, they are always in motion? No, not in the same direction and the same speed. They move randomly, non-stop, but they collide. And their collisions are elastic collisions. So the answer is B. What type of collisions occur between gas particles? I said it in the previous question, elastic. What does elastic means? It means they collide, they bump into each other without losing their energy, without losing their energy. It's not like they're gonna collide and collide until they stop. No, they will collide and keep on colliding, and they will never stop. So that's why we call their collisions elastic. Why there are no attractive forces between the gas particles? Why? Because they are far away from each other. So there is a lot of empty space between the particles. So that's why they have no attractive forces. They're too small. They're tiny, small particles. The forces, they don't cancel. They are not too heavy. No. They are far apart, and because they don't have attraction, they move fast. Which assumption explains why ideal gas collisions are considered elastic? Particles, definitely they do have a volume. It's very small if I want to see the size of the particle compared to the volume of the container. The size of the gas particles, true, it is very small, but it doesn't explain why the collisions are elastic. Gas pressure is not zero, but they are perfectly elastic and they don't lose their energy after colliding because there are no attractions between them. That's why they don't lose this energy. How do gas particles move at room temperature? Stationary means they don't move. Move only when heated, that's not correct. They keep on moving in all kind of directions, in random directions. Now, let's continue. So, which gas in the following list is diatomic under standard conditions? I gave you the list of diatomic molecules. There's 7. So I'm gonna mention it here. Hydrogen, nitrogen, oxygen, and fluorine and chlorine. These are diatomic that are gas. Bromine is the liquid and iodine is the solid. These are the diatomic. So that is the only diatomic molecule over here, and it is gas. The rest are not even diatomic. This is complex, and this is monoatomic. True, all of the given choices here are gases, but this is a diatomic gas, this is a a complex gas, that's a complex gas as well, and that's a monoatomic gas. Which gas in the following list is monoatomic? So as I mentioned in the previous question, that's the monoatomic. These two are diatomic, and this is a complex, but all of them are gases, by the way. How does increasing the temperature of a gas affect the pressure? When temperature is increased, the particles, they move faster. And by moving and bumping faster, the collisions are going to be stronger, which increases their pressure. So pressure increases because temperature increases. What happens to the pressure inside a balloon when the balloon is cooled? So let's go back and look. If I'm going from here till here, when a balloon is cooled, the particles are going to slow down. They're going to collide, but not as much as hard as when they were hot. And when the collision are a bit weaker, the pressure goes down. What happens to particles collision when the volume is less? Look at this one. When I decrease the volume, the particles come closer to each other. So they become closer and the collisions become stronger because they're next to each other now even more. And when the collisions become more, like you increased the frequency of collision by bringing the particles together, pressure increase. So collisions increase, pressure increase, volume decrease. So pressure and volume, by the way, are opposite to each other. What happens to the pressure if I have more gas? It becomes crowded. And when it becomes crowded, it means more collisions. And when I have more collisions, I'm going to have more pressure. So in this one, pressure increase. What happens to the pressure when you blow air into balloon? You are adding more gas into the balloon, more gas particles in the balloon. Remember, if I have a football ball and it's soft, I need to blow it with more air to become strong and hard so that I can play with it. So blowing more gas into the balloon increases the pressure of that balloon. How does increasing the speed affect pressure? Increasing the speed, they go crazy. They bump more into each other. The collision becomes stronger, harder, so the pressure increases. And now we reach the part of conversion. A gas has a pressure of 150 kilopascal. Convert this pressure to both atmosphere and millimeter mercury. So, in your exam, you're going to have a formula, a conversion factor that says 1 atmosphere is equal to 101.3 kilopascal and 1 atmosphere also equal to 760 millimeter mercury. We are going to use this conversion factor in order to convert the 150 kilopascal into both the atmosphere and the millimeter mercury. So, I'm going to explain this in two ways. 150 kilopascal multiplied by, you use the given and you write down in the conversion factor, in the denominator of the conversion factor, the kilopascal, which is 101.3 kilopascal, to be eliminated, and up in the numerator of the conversion factor, the unit that you want to convert to, which is the atmosphere. And 101.3 kilopascal is equal to 1 atmosphere. And like this, you solve, and then you get the answer in atmosphere, which is equal to 1.48 atmosphere. Now also the question asks to convert again this 150 kilopascal into millimeter mercury. So again, in the conversion factor denominator, I'm gonna place the 101.3 kilopascal as I want to get rid of the kilopascal, and in the numerator, the unit that I want to convert the kilopascal into it, which is 760 millimeter mercury. So the answer is going to be 1125.3 millimeter mercury. Now there's another way, in case you do not prefer this way, which is you write a ratio. So let's do here the kilopascal question in order to convert it to atmosphere. So in the numerator, you write the equal units, which is 101.3 kilopascal, which is equal to 1 atmosphere. You write it facing it. And we want to calculate this pressure in atmosphere, so I'll put X, and down here I'll write the given. The given is 150 kilopascal, and I'll do cross multiplication. So to find X, we do 150 times 1 over 101.3 kilopascal. We get the same answer to be 1.48 atmosphere. Again, I want to convert the kilopascal into millimeter mercury. So I use the same conversion factors. 101.3 kilopascal is equal to 760 millimeter mercury. So down here, I'll write the X that I want to convert into millimeter mercury and the 150 given in the question. And I do cross multiplication to get X. So X is going to be 760 times 150 over 101.3 kilopascal. And like this, we'll get 1125 millimeter mercury as an answer. Moving on, which of the following substances does have a limited translational motion? We studied translational motion, rotation, and vibration. Vibration goes only for solids. Liquids, they do have vibrational motion, rotational motion, and a limited translational motion. Whereas gases, they have all the kind of motions, translational, rotational, and vibrational. So I'm going to write it here. For solids, it's only vibrational particles of solids, they vibrate. For liquids, particles of liquids, they rotate, rotation, they vibrate, vibration, and limited translational motion. Whereas for gases, they move in all kind of directions, so they have a rotational, vibrational, and translational without any limitations. So which of the following does have a limited translational motion? That is the liquid. Which of the following substances can make fully translational motion fully without any restrictions? It's the gas. So in this case, we choose option C. Which of the following substances can form hydrogen bonds? Hydrogen bonds are observed in polar molecules, specifically containing H and O or H and F or H and N. So within the given options, H2O will form hydrogen bonds between their molecules. Now the intermolecular forces that we studied this term, intermolecular forces, are observed within covalent compounds, and they are in order: London dispersion forces, which are the weakest, and then stronger you have the dipole interactions, and the strongest are the hydrogen bonds, which are a type of dipole but stronger than dipole. So London dispersion forces, now these forces result, no, we're talking about intermolecular forces, so they do not result from covalent bonding. They are not present in ionic compounds because we studied the intermolecular forces between covalent compounds. They are the weakest, so hydrogen bonding are the strongest. And these are the forces arising from temporary, or we might call it instantaneous dipoles. So that's why they are weak. And London dispersion forces, they are the result of the motion of the electrons, the movement of the electrons in the atoms. So those instantaneous dipoles created by the motion of the electrons makes them the weakest. And they arise specifically in non-polar molecules. What I mean by this is that non-polar molecules, they only experience London dispersion forces. They do not experience dipole-dipole or hydrogen bonds. Whereas if I have polar molecules will have London dispersion forces, but additionally, they will experience also dipole-dipole interactions. Sorry, and if these polar molecules had oxygen or nitrogen or fluorine and hydrogen atoms, they will also experience hydrogen bonds. Intermolecular forces can be defined as forces that holds not the ions, they act between molecules, and the intermolecular forces, they affect the physical properties of the compounds. They are the one that will affect whether the compound is going to be solid, liquid, or gas, viscous. They will affect the melting and the boiling point, whether they are high or low. Which of the following factors most directly increase the strength of London dispersion forces? Now, the London dispersion forces are the result of movement of electrons in the atoms of those molecules. So, and those electrons, when they are moving, they create temporary dipoles. So if we have in the molecule more electrons, those London dispersion forces are going to be stronger. So what influence the strength of the London dispersion forces is the amount of electrons in the molecule. Now here in the choices, they're talking about hydrogen bonds, protons, electronegativity difference. But if I look at choice C, larger molecular size, what does it mean, larger molecular size? Bigger ones. It means they contain more electrons. So that would be our answer. Which statement correctly explains why larger molecules have stronger London dispersion forces? Larger molecules, they have stronger dispersion forces because they will have larger electron clouds. It means they will have more electrons, which makes their temporary dipoles stronger. Intermolecular forces, what is their definition? Intermolecular forces can be defined as forces that act between the molecules, not inside the molecules. They are the forces between the molecules influencing their physical properties. Let me just double check here. Yeah. Now, so I mentioned this. So they are the forces between the molecules. Which of the following factors most directly increase the strength of London dispersion forces? Oh, this is a repeated question. Larger molecular size. And here, larger electrons. This is a repeated question. And that's it, the end of the video tutorials of the answers of the focused questions in details. I wish you all the best in your exams.